Welcome. We're going to be going through the Unit 9 study guide for Algebra 1. The focus is on solving inequalities, being able to graph our solution, and then also writing out the solution in both set builder notation and interval notation. Let's begin. We're going to follow through our solving equations process, but applying that to inequalities. So remembering that our acronym is DCVAM if you need that to help you organize. And again, if you like to draw your line down the equal sign on equations, you can also draw your line to split the inequality there. So D is for distributive property. I'm going to do -4 times W as -4W. -4 times -8 makes +32. Keep the less than symbol. And then we have no parentheses on the right to distribute. Bring down that -50, bring down that +2W. Distributing done. C is for combine like terms. On the left side of the equation, I have a variable and a constant, nothing to combine. On the right side of the equation, I have a constant and a variable, nothing to combine, so that's taken care of. V is for variables. Move all of the variables to one side of the equation. So we're going to pick one that we want to cancel. I'll go ahead and cancel on the right. It's a +2W, so my inverse is -2W. Remember, what you do to one side, you have to do to the other side. So -6W then, after we do that arithmetic, +32 comes down, less than comes down, -50 comes along, and then notice that 2W and -2W, that has canceled each other out as we intended, so that we could get it off the right side. So variables are all now moved. The A is for add or subtract as you need to with your constants. So I'm going to have to use the inverse of +32. That's -32. What I do on one side, I have to do to the other side. So -6W then stays behind. The less than symbol comes along, and we're now at -82 for that after we do our -50 and -32. There's our adding and subtracting. Good. Lastly, the M there stands for multiply or divide. And so that's to cancel your constant. We're going to divide both sides by a -6 in this case. And I do hope that you remember anytime that you are dividing by a negative on both sides, or even multiplying by a negative on both sides, that tells you that you need to flip the inequality. So, given this information, my W comes along, but I flip the inequality. It's no longer a less than. Now you're looking at a greater than, and we're going to simplify the fraction. -82 divided by -6 comes out as 41/3. There is our solution. We're going to go ahead and plot this on the number line. And when I mark that down, right, 41/3, well, just above it would be 42/3, but recall that's actually now going to be evenly divided. So 42/3 can be relabeled as 14, and then you can keep on counting to 43/3 or count below to 41/3 and then 39/3. Also, this fraction can be simplified to 13. So you have a little bit of an idea. 41/3 then is between 13 and 14 on the number line. And we're going to consider how we plot that. So at this value for my solution, 41/3, look at your inequality symbol to decide if it's an open point or a closed point. There's an empty space below the inequality, so there's going to be empty space on the point that you plot. And then I'm looking for the numbers that are greater than 41/3. Find the things that are greater than it by heading to the right. That's where you're going to shade this inequality. Now, to write that out in set builder notation, remember, set builder always begins and ends with the curly braces. Introduce the variable that you are talking about. It was W in this case. Do your vertical bar for such that to say we're done with our introductions. Now we're ready to talk about the math. And whatever your solution was gets filled in. So W is greater than 41/3. There you have it. The interval notation is going to be based off of our number line, again, telling us where we start and where we start. Where we start and where we stop, always working from left to right on the number line. So coming from the left, the starting value there is at 41/3. You have to decide if you open this with a bracket or a parenthesis. That's based on what kind of a point on your number line. It's an open point, so that gets a parenthesis. Then put your comma in. Follow this all the way down to the right to an arrowhead. That arrowhead on the right points to positive infinity. And remember that curvy infinities are always wrapped with curvy parentheses. As we go over to example B, Then again, I'll split that inequality down and I'm going to follow through this same process again, focusing on that DC VAM just to make sure that we keep those ideas straight. So D for distribute, it is the -3 in front of these parentheses that we're going to distribute. 9 comes down just like it is. It's the -3 that starts to distribute for -3n, and -3 times -5 then for the +15. Bring down everything else, the 15, the -6n, and that greater than or equal to. Distributing is done. C for combining like terms. I've got a constant and a variable on the left, so there's no combining. On the right, then, I see that I have a constant 9 and a constant 15. Those can be added together to make 24. Still bring down that -3n, and everything else stays the same. 15 minus 6n, and this is greater than or equal to. So there's my combining. V for variables, then focus on that. All your variables have to go to one side. And I'm going to go ahead and cancel on the right. So I will add 3n as the inverse of a -3n. What I add to one side, I have to add to the other side as well. We can see that cancel. So we're going to combine. Then 15 minus 3n after you do that arithmetic is greater than or equal to 24. Let's get the variable together. A for add or subtract. Add or subtract those constants away. So my +15 now needs a -15. And what you do to one side, we're going to do the other. So -3n is greater than or equal to, and let's see, 24 minus 15 puts us at 9. Lastly, when you use the m for multiply or divide with your constants, I'm going to divide by a -3 and divide by a -3. Notice when you divide by a negative number on both sides, this is going to flip the inequality for you. So my n comes down. My inequality was a greater than or equal to. Now it is a less than or equal to. And the 9 divided by -3 gives us -3 for that solution. We're going to go ahead and get our number line set up for this. So a -3 and mark it out as well around it, -2, -1, -4, -5. And let's think about how we're going to plot this point. My value of -3, look at the inequality to decide about the point. It has the extra underline for equal to. It is included. So we're going to have a closed point. Remember, extra ink to draw the underline and the equals, extra ink to fill in the point. Now you're shading for values that are less than -3. So the things that are less than it are heading off to the left side. We'll go ahead and put this into set builder notation. Set builder always opens and closes with the curly braces. Introduce your variable. That was the letter N we talked about this time. Vertical bar that says such that tells you we're done with the introductions and now we're ready for the important stuff. Use that inequality and fill it in. N is less than or equal to -3. That interval notation, then, we're going to start on the left and work our way to the right. So starting from the left, I have an arrowhead. Arrowheads pointing to the left tell me -infinity. And remember that curvy infinities always have curvy parentheses in interval notation. You put your comma in because now we're ready to talk about the right side of our number line. And the right value that we stop at is -3. Notice this is a closed point at that -3. Closed points are included. They get brackets. So down here to option C then for our next problem. And again, we are going to have to follow through with that idea of solving an equation to solve this inequality. So D for distribute. -3/4 times 2k would be -3/2k. And then -3/4 times the +5, that is a -15/4. This is all still less than or equal to 5. So if you wanted to see that multiplication slowed down a little bit, let's go ahead, -3/4 multiplied by the 2. So I'm thinking about that as 2/1. And then I see where I can simplify my fraction. That 2 and that 4 both have a common factor of 2. So 2 divided by 2 left me with 1. And the 4 divided by the very same 2 leaves me with 2. So I multiply that straight across the numerator now. -3 times 1 is a -3. And across the denominator, 2 times 1 makes it a 2. So that's how I came up with my first term, -3/2, still with the k attached. Also then, with the other piece of that we did, when we had the -3/4 times the 5, I thought of that as 5/1. And when I looked at that, I didn't have any common factors in the numerator or denominator for the multiplication. So I just went ahead straight across. In the numerator, I did -3 times 5, that was negative 15. And in the denominator, I did 4 times 1, that was 4. And there was nothing to simplify. That's how we got the negative 15 over 4 into our problem. Now, continuing on with our solving, now that the distributing is done, we're going to see if we can combine like terms for that letter C. A variable and a constant won't have anything to add, so we can skip that step. V for variables to move them all to the same side, and I only have one variable showing up. Don't have to worry about moving them. A for add and subtract now. So my negative 15 over 4 needs an inverse. Let's add 15 over 4. And what you add to one side, you have to add to the other side. So that 5 that I have needs to be added on with a 15 over 4, which means that somehow I need to turn that 5 into a something over 4 so that I can add it on with that 15 over 4. So the real question is, if my 5 over 1 is here, what is it that I multiplied 1 by to turn into a 4? Well, that was multiplied by 4, so the same thing has to happen. That 5 also needs to multiply by 4, so I'm now talking about 20 there. So when you go ahead and add those, the 5 plus the 15 over 4 is going to be giving me the 20 plus the 15 for 35 over that 4. Again, we added across the numerator to get my 35, and we had like denominators. You keep the like denominator in your answer. You worked so hard to make the match for the adding, so you keep it in the same. Right? I still have that less than or equal to sign, and I still have this negative 3 halves k. So lastly, after we've done that adding and subtracting, now we're going to go ahead and multiply or divide. So I want to divide by my coefficient, but wait, we're looking like we're going to have to divide by a fraction. We don't divide by fractions. We are going to have to multiply by the reciprocal. So I'm going to multiply by 2 negative 2 over 3, multiply my other side by the negative 2 over 3 as well. So on the left side, this works well. 2 numerator and 2 denominator cancel, 3 numerator and 3 denominator cancel, negative times a negative makes it positive, so k has been left behind. And notice we used that negative to multiply. We used that negative to multiply. That's what tells us that we need to flip our inequality sign, so it's now a greater than or equal to that we have. Let's continue on with that multiplying on the right side. So I have a 2 numerator and a 4 denominator. Both can divide out of 2. So 2 divided by 2 leaves us with 1. 4 divided by 2 leaves us with 2. Multiply straight across the top. 35 times 1 leaves us with 35. And then 2 times the negative 3 leaves us with negative 6. So here's our solution. You may have chosen to write that negative in the denominator, or you may have seen it show up in the numerator, or some of you may have also just written it in front of the fraction as a negative 35/6. Any of those variations is okay for your solution. We'll go ahead and plot that on the number line then. Let's see, negative 35 over 6 is on there now. And as I go a little bit below that, I'll get to negative 34 over 6 and negative 33 over 6. Moving to the left, negative 36 over 6. I hope you recognize that's going to simplify as a negative 6. And then above it, or excuse me, I guess I should say below it then on the left, negative 37 over 6. And yes, there are a couple of these others that could simplify, right? That negative 34 over 6, certainly, while it's not going to simplify to an integer, both of those are even. You could relabel that as a negative 17 over 3. And that negative 33 over 6 that you have in the next position, well, notice both of those could divide out a 3 from there. So maybe you'd write that as a negative 11 over 2. I'm trying to help you organize that. Now, let's go ahead and plot. So, at my value, look at the inequality symbol to decide what kind of a point you will have on there. Extra ink to draw the underline, so extra ink to fill in the closed point that you have on your graph. I'm looking for the values that are greater than this value. So greater than is going to shade towards the right, towards those positive values. Turn this into some set builder notation then. Open it up with curly braces, introduce your variable, write the vertical bar that says we're done with the introductions, and then you get to write in that inequality that you solved for. So k is greater than or equal to the negative 35/6. Don't forget to close your curly braces when you're all done with that. As for the interval notation with it, start on the left side of your number line with the smallest values that you have. negative 35 over 6. That has a closed point, so that gets a bracket, comma, and so we're moving this all the way over to the right. Arrowhead to the right takes me up to positive infinity, and all of the curves in the infinity remind me of the curve in the parentheses to finish that interval notation. Last one on the frontier for letter D. If we think about that DC VAM process again, D for distribute, so it's the 4 times P for positive 4P, and 4 times negative 10 makes negative 40. Gonna bring down everything else just as I see it. Keep the 80, keep the less than, keep the negative 10, keep the plus 4P. C4 combine like terms next, so I've got an 80 and a negative 40. That'll make 40, and still plus 4P. Keep the less than, and my other side's got a negative 10 plus 4P. There's my combining. V for variables, I got to get all the variables together on one side. So on the right, if I want to cancel positive 4P, I use negative 4P. Do the same negative 4P on the other side as well. And oh, notice that cancels. All right, so 40 now is less than negative 10 is what I'm left with. All the variables are gone. 40 is less than negative 10. I hope you realize that that is a false statement. A positive cannot be less than a negative number. Anytime that your variables cancel and you have a false, this gives you a no solution. We have no solution available to this. And so on your number line, what would you see? Well, it's going to end up as a blank number line. I like to write NA on it just so that I remember I didn't actually skip it, but that I left it blank for a reason. There's no value that we can mark on this number line, which will make the expression true. So what does that look like on our set builder notation? Set builder, again, has the curly braces in it, and you use the null set or empty set for it. Interval notation just uses that null symbol on its own. There's no start or stop for the interval. It's just empty, nothing we can do about it. As we go on to the back and check out this next example, we're going to have to distribute through here. So negative 4b plus 84 stays the same. It's still greater than or equal to. And we're going to go ahead and distribute negative 12b and distribute for a positive 60, bring down the plus 5b. Combining like terms, I don't have any like terms on the left. Keep that the same, greater than or equal to. And combine a negative 12b with a positive 5b. That makes negative 7b, and bring down the plus 60. I want to move all my variables to one side. I'm going to add 7b to cancel that negative, and what I do to one side, got to add the same 7b to the other side. So I've canceled on the right, combining these on the left for some arithmetic. I've got 3b then plus 84. This is greater than or equal to 60. We'll go ahead and I need to subtract that 84 from each side. So that 3b then is greater than or equal to negative 24 there. 60 minus 84 gives me negative 24. Got to double check my arithmetic. Divide both sides by my coefficient of 3, so b is greater than or equal to negative 8. There's my solution. While we did have a negative number involved in the division, that does not indicate that I'm flipping my sign. It has to be the number in the denominator that I'm dividing by on both sides to flip the inequality. So this does stay as that greater than or equal to. Go ahead and mark off on your number line there. So negative 8. And we'll put some other values around it to give orientation. It's greater than or equal to, so I'm going to have a closed point on my number line there, and I'm looking for the values that are greater than negative 8. The things that are greater than negative 8 are going to be towards my positives, so we're shading to the right. Set builder notation for it. Open up those curly braces, introduce the variable, put your vertical bar that lets us know we're done with introductions, and then fill in your solution. B is greater than or equal to negative 8. Close those curly braces because we're done. Interval notation, start on the left side of the number line. The first thing you find is that negative 8 with our solution. It has a closed point, so you use a boxy bracket. Comma, tell me where we go on the right end. That's an arrowhead taking me all the way up to positive infinity. The curves in infinity remind me of the curves in parentheses to close it off. And then as we come over to example F, when I split that up, D for distribute, I don't have any distributing to do, but I can combine like terms. 8W and negative 6W are going to give me 2W. This is less than or equal to 24. And some more like terms then. A negative 9W and a negative W goes negative 10W when we add. Let's move all the variables over to one side. So I'm going to add 10W and add 10W. So it sounds like 12W now is less than or equal to 24. I'll go ahead and divide both sides by my coefficient of 12. So W now is less than or equal to 2. There's our solution. Going to go ahead and mark that on the number line, put my solution value 2 on there, and surround it with some other values. And notice now, my 2 has the underline with it, extra ink to draw the underline, extra ink to fill in the point on that graph. And W is less than or equal to 2. So things that are less than 2 are going to be like 0 or 1 or the negatives, shading to the left there. Set builder notation always has the curly braces. Introduce the variable W, vertical bar for such that, and then you fill in that solution, less than or equal to 2. And then the interval notation. Start on the left. What's the smallest thing that you put? The arrowhead that points to negative infinity is where we start. Curvy infinities always get curvy parentheses. Put your comma and follow it to the right all the way up to your ending point. That's at 2. It's a closed point, so it gets a bracket. As we scroll on down, number 2 there also wants us to solve the inequality, and then we're going to pick all of the solutions that would fit into this. So let's begin by solving. We'll need to distribute the invisible 1 here. So 2h and 1 times 2 makes 2. Positive 1 times negative 7 makes negative 7h. And then I've got to distribute the negative 3. So minus 3h, negative 3 times 6 makes negative 18. This is all less than 24. Combine some like terms, so 2h and negative 7h and negative 3. So 2 negative 7 makes negative 5, and then with a negative 3, that's going to put me at negative 8h. And then when I look at the constants, a positive 2 and a negative 18, that's negative 16 for me. This is still less than the 24. Gonna have to cancel out the constant. I've got a negative 16 right now. Let's add 16 to both sides. So negative 8h is less than 24 plus 16 puts us at 40. Let's see. And divide by my negative 8 and divide by my negative 8. Notice we divided by a negative on the left and we divided by a negative on the right. That tells me to flip the inequality symbol. It's no longer a less than. Now I have a greater than. So h is now greater than negative 5 when you do that arithmetic. So this is my solution. But what does it actually mean? I'm thinking about this on the number line. Right, negative 5, negative 4, negative 3, and then this way I've got a negative 6 and a negative 7. And when I picture that, an open point at negative 5 and things that are greater than it are heading off to the right. So I'm thinking about this as I try to answer these questions. Is this negative 3 value part of the solution? Is negative 3 underneath of the shading in my arrow? Yes, it is. So that is a possible solution. Is 0 underneath the shading? Well, yeah, we'd have negative 2, negative 1, 0. Is this underneath the shading? Well, maybe not right now, but remember that arrowhead means that it keeps on going. So yes, in fact, it is. 0 is still underneath of the shading. Negative 5, look at that, negative 5 right there with my open point. It's at the solution value, but because this is an open point, we cannot include it, right? Open points are not included in the solution. If this was a closed point, then absolutely we would circle the negative 5. Think about 5, that's a positive. Going down here, we already had 0 on there. Keep going more into positives, and your arrowhead is still going to be more on top of them. So yes, indeed, that 5 positive value is included. I've got negative 8. Well, negative 8 is going to be down here. That's not in my shading, not under the arrow. Negative 1, yep, we already put a little digit for that. This is definitely underneath of my arrow, include that. And negative 6, you can see it, not underneath of my arrow, not underneath of my shading. So we had 4 of these values that were provided as possible solutions. Okay. Number 3 wants us to work on graphing these number lines, making sure that we are seeing them correctly. So for this first one, I'm focusing on negative 4. Label some values that are above it and below it as well for negative 3 and negative 5. And in this case, x is greater than or equal to the negative 4. So the or equal to tells me it's a closed point. Greater than this says we're shading to the right. On that next number line, -9 is the value that I need to focus on, as well as some values around it, -8 and -10. Now, -9 has a curved parenthesis on it, so that would tell me that it has an open point. And I'm going from -9 towards infinity, towards positive infinity. Positive infinity ends up on the right side there. Now, my next one, interval notation is given here, focused on 6. Label the number line around it, where it goes up to 7 and down to 5. 6 is the solution value that I care about here. And so I'm starting at 6. It has a bracket, so it is a closed point. Bracket says it's included, closed point says it's included. From here, from 6, I go all the way towards infinity, so I'm going all the way to the right for positive infinity. And lastly, with the set builder notation, I'm focused on 10, label some points around it, like 9 and 11. I see a less than symbol, that's going to be an open point. And then I'm looking for the values that are less than this. So less than it is going towards 9, towards 0, towards the negatives. All right, the final question that we have gotten to now says you're getting married and we've chosen a wedding venue. Now we have to know about the number of guests that we're inviting. So, given the cost of the venue as $1,200 and $40 per person for food, but I cannot spend more than $4,750. Write an inequality to express this. So, my inequality is going to take the cost of the space, $1,200, plus the $40 per person. So, my 40 times the number of people that I invite must be less than or equal to $4,750 so that I stay within budget because I can't spend more than that. So the Part B follow up says, what's the maximum number of guests that I can invite and still stay within the budget? So I need to solve this inequality that I have. Let's go ahead and subtract the 1,200 from each side so that I can isolate this variable. So 40p is less than or equal to 3,550. Divide both sides by that 40 coefficient now. So p is less than or equal to 88.75. So, can I invite a 0.75 of a person? No, I can't. You're not allowed to invite partial people. You're not allowed to ask anybody if they're willing to do a magic act and only bring half of themselves to the wedding while they leave the other half at home. It doesn't work that way. So, what does this mean? If I have to be less than 88.75, I have to be less than a whole number. So, that's going to be that 88 or less people can come to the wedding and keep me within budget. I hope you're feeling a lot more confident now with solving, graphing, and the different ways that we can write the set builder notation and interval notation for all things inequalities. Have a fantastic day. and then you follow that number line all the way to the right. Your arrowhead points up to positive infinity. Curly infinities always get curly braces. Okay.